What is the meaning of coupling? It measures the relative interdependence among modules. Two design strategies, one is the top-down approach and the other one is the bottom-up approach. Hello and warm welcome to one and all. It is Dr. Ravi Kumar YB, Department of Computer Science, Vidhyaashram, First Grade College, MYSURU, the Temple of Excellence. In today's session, you will be taught about the modular design, that is the software design principles. In this case, you have what is the meaning of modular design. As I have already told you in the previous session that if you have a big problem that has to be reduced into smaller sub-problems so that the solution to the smaller sub-problem will give you a solution to the bigger problem. If that is the case, let me take you into the details of modular design. That means modular design reduces the design complexity and results in easier and faster implementation by allowing parallel development of various parts of a system. That means if there is a big problem, that is the complexity of a problem is very big, then obviously this leads to the smaller sub-problems. This may be assigned to team 1, team 2, team 3, team 4, so that all these teams will be working on parallelly, and finally the solution of T1, T2, T3, T4 is integrated together to get a solution of this. So this becomes a faster implementation, that is the development of a system. The same thing is explained here. In this section, you are going to learn what is that functional independence. The functional independence includes that it is achieved by developing functions that perform only one kind of task and do not excessively interact with other modules. That means it performs only one task. This performs another task, another task, another task. But it does not depend more on T2. That is the development team T2, what it is being done, that is T2 is doing, and T3 and T4, all these. T1 is not at all dependent on any of these modules of any of those teams. That is the meaning of that. Then we have independence. Functional independence is important because it makes implementation more accessible and faster. As I have told you earlier, that means it becomes faster. The independent modules are easier to maintain, test and reduce error propagation and can be reused in other programs as well. That means we can reuse the functionalities of those modules into any of the projects which we have in the future. So the functional independence is a good design feature which ensures software quality. Very, very important here. So it is measured using two criteria, software quality, using two, that is cohesion and coupling. What is the meaning of cohesion? That means it measures the relative functional strength of a module. That means what is the functional strength of this module 1 with respect to module 2? Is there any dependency between those two? That is determined with the help of cohesion. What is the meaning of coupling? It measures the relative interdependence among modules. Interdependence, please note that we have a module M1 here, module M2 here, module M3 here. We have a coupling of this. That means this. If there is any dependency, interdependency between M1 and M2 and M1 and M3, that has to be determined with the help of this coupling. Cohesion means relative function strength of a module. What is the strength of this module with respect to this? That means independence, functional independence. What is the strength of this module? Strength of this module. Then, is there any interdependence between those two? That is called as a coupling. Now, information hiding is the next important thing, wherein you will learn that only the relevant information is given to the user. All other irrelevant information are hidden from the user. That is the meaning of this. That means the design decisions that protect from others. That means other irrelevant information is not at all given to the user. Only the relevant information is given to the user. That means modules should be specified that the data included within a module is inaccessible. That means providing security to the user, the security to the data, to other modules that do not need for such information. If that is the case, modular design also supports that the user information hiding a design criteria for modular system provides the most significant benefit when modifications are required during the testing and after software maintenance. Once the development is over, the testing and maintenance is the main important part. In this case, testing and maintenance, we have the term that is modular design, which is most significant, and it helps the user to come with many modifications so that the modifications can be incorporated very easily. So this is because the most data and procedures are hidden from other parts of the software, and inadvertent errors introduced during modifications are less likely to propagate to other locations within the software. That means if there is any modifications to be incorporated into the existing system once after the delivery of a system, that means the delivery of a software to the end user, he may come up with few modifications. Once the modifications are informed, that can be easily incorporated, and the locations where the modifications are incorporated will not propagate into another modules. So that has to be maintained very effectively using the module independence. That means the functional independence property of that. That means the cohesion property of that. A good system design strategy is to organize the program modules in such a way that the method that is easy to develop and later to. That means during the time of development as well as after the maintenance. That means once it is delivered to the end user, it may also be reused to incorporate any modifications to it. If that is the case, the structured design methods help the developers to deal with the system and complexity of the programs. If that is the case, analysts generate instructions for the developers about how code should be composed of and how pieces of code should be fit together to form a program. That means the module 1, module 2, module 3, module 4, so on. All these modules can be incorporated and integrated together to get solution to one big problem. That is the thing we are going to analyze using the analysis. So if that is the case, we have two design strategies. One is the top-down approach and the other one is the bottom-up approach. In case of top-down approach, we will divide the entire problem into smaller sub-problems, that is in the form of a binary tree. That means this approach starts with identification of the main components, that is the main problem, and decomposing them into more detailed sub-components. That means bigger problem is divided into smaller sub-problems. There are pictorial representation of this. The level 1 contains more complexity. The level 2 contains less complexity. Level 3 contains even less complexity because we have divided the complexity of this into 2. And again, we have divided the complexity of this into 2. This, if I combine these two, I'll get more complex information here. So by dividing this in the form of a top-down approach, obviously at this level, that is at level 3, we will be having a less complexity so that the solution to this less complex problem can be obtained very easily. So this is how the top-down approach is used. Moving on to the bottom-up approach, we will have the modules first here. That means smaller sub-problems are used here and the solution to the smaller sub-problems are integrated together. Smaller sub-problems are integrated together. Then we have the integration of solution to the level 2 to level 1, level 3 gives me the solution to the entire big problem. So what is that? During the time of development, we will follow the top-down approach. During the time of integration of all these solutions to the one single problem is followed in the form of bottom-up approach. So we will use both top-down approach as well as bottom-up approach to find out a solution to the complexity of a problem. So differences between the structured and object-oriented analysis. How do you know that the differences between the object-oriented and the other one is structured-oriented approach? If you take up the example of a C language, you will see that it is a structured-oriented language. That means whatever the variables you use in the programs are going to be declared earlier and then it is going to be used. That is the functionality of the structured-oriented approach. If you move on to the object-oriented approach, it is a bottom-up approach. Every functionalities must be defined later, must be defined earlier, and all those main functions are defined at the later part of the program. That means the bottom-up approach is followed in the object-oriented approach, whereas in the structure-oriented approach, the top-down approach is followed. For example, C is a programming language that follows the top-down approach, and C++ is a programming language that follows the bottom-up approach. If that is the case, analysis simply means that it is to examine the structure of something, elements, system requirements in details and methodological way. Structured analysis and object-oriented analysis both are important for software development. That means both C and C++ kind of oriented approach is important here, and analysis techniques used in software engineering, but both are different from each other. How it is different from one another? That means how structured-oriented approach is different from the object-oriented approach. Let me clarify you that. If that is the case, structured analysis method of development allows and gives permission to the analyst to understand and know about the system and all of its activities in a logical way. That means structured analysis helps the analysts to analyze and design and implement the system in a more logical manner. That is the thing. That is in case of structured analysis. It is simply a graphic that is used to specify the presentation of the application. That means whether it may be a GUI or any of these applications can be developed. If you look at this, we have the figure here, account application here, create a new account balance, that create new account with no balance, that is zero balance. We have the customer makes a purchase, that means active account balance. Once when the account balance is there, we will go for closed balance or with bad debt. Suppose if there is no balance in this account, we will go to the active balance account, we will close the balance account, or else we will say that the bad debt account balance. So this is the transition diagram, state transition diagram example that gives you the example for this structured analysis. Moving on to the object-oriented analysis, we have the object-oriented analysis. It is a technical approach generally used to analyze and application designing, that system designing, even business designing, such as by applying object-oriented programming, even with the visual modeling throughout the process of development. What does this mean? The object-oriented approach, that is C++ and Java oriented approaches, that is bottom-up approach, is used. A bottom-up approach is used to find out the analysis of this problem definition using the object-oriented approach. If that is the case, the process of discovery where a team of development understands and models of all the requirements of the system. That is the meaning of that. If you look at this diagram, that is this state transition diagram, we have user initially at this point, pending, there is no account created. Once when it is approved, it becomes to the active state, then it moves to the deactivate state. Before moving on to the deactivate state, it is deactivated by the user, activate the user. Suppose if they wants to activate, let them activate it, and if it is pending, it is approval is not over, then it is rejected. That means it is deactivated. Directly we have the operations like this. Once we have it, we are in the pending. If it is approved, we will move to this active state. If it is not, then we will move on to the deactive state. From here, we can delete the user. That is the state transition diagram that explains about the object-oriented approach. This is called as one of the object, object, object. So we have three objects here. Object 1 is indicated by the status of the account information. Object 2 indicates the status of the account information, that is deactivated or activated. Once this gives you the pending information, that is whether the account can be created or not based upon the approval. That is going to be taken, and it is considered as the object 3. So object 1, object 2, object 3 are integrated together. That is the solution of this to find out three important functionalities are integrated together to get one function. That is to obtain this. Finally, it is deleted if the account holder does not want to have an account in this. So structured analysis and object-oriented analysis, that is the difference between these two. The main focus is on process and procedures, that means top-down approach. In this case, we focus on objects, not on functions, because it is a blueprint. It uses the system development life cycle. That means the analysis like planning, analyzing, designing, implementing, and supporting on information. But in this case, it uses an incremental or iterative type of approach for developing a model. It is suitable for well-defined projects with stable user requirements. Suppose if all of the requirements are suitable and stable, then we can go for the structured-oriented approach. Otherwise, we will go for the object-oriented approach. This is suitable for large applications. That is suitable for smaller applications. Then, risk while using the analysis technique is high and reusability is also low. That means we cannot reuse the existing code for that. But in case of this, we can reuse the existing functionality, and also the one thing you need to notice here, the reusability is also high here, but in this case it is very low. We cannot reuse the component much in number. That is, the structure-oriented design includes the flowcharts like data flow diagram, structured in English, entity relationship diagram, CFD, that is control flow diagram, data dictionary diagram, or decision table or tree state transition diagram. All these are examples of this structured analysis. But in case of this, we will have object-oriented and modeling is one of the subject that gives you the information of these diagrams like use case diagram, flow of event, activity diagram. All these are certain types of mapping operations, state chart diagram and deployment diagram. All these are examples of object-oriented analysis. This technique is new and is mostly preferred, and this is old and it is not preferred usually, because these are the traditional type of approach for finding a solution to the problem. This is a new type of approach that is being used in industry, that is the object-oriented approach. And if they want to design any of the models, then they will go for these type of diagrams. So with this, I'm going to conclude this session. Thank you very much. Thank you one and all. Kindly come to the department for if you have any queries. I will solve it in the department. Thank you very much. Thank you one and all.